Hello class, so this is the SDL and the Flying Cow. So this is going through circular motion. The lab itself is not complicated, but knowing exactly how to do the lab is, so I'm going to outlay everything clearly. If for some reason you're not using audio, use audio, because in case you couldn't hear me, now hopefully you are using audio. I'm going to talk a lot more than I write because there's only so much room to write and writing is slow. Alright, so now that we get cleared that, hopefully you saw the flying cows in lab today in class. So we're going to have to do both a kinematics and a forces to figure out the circular motion, and what we want to find is the tangential velocity. There's basically two equations we can use to do that. Alright, so these are two equations. It's force is equal to m, which is mass, over v squared, which is the velocity, over r. So our goal for you is to find what v is in both of them. V would be our unknown. The second one is v equals 2 pi r t. Remember, r is the radius, t is the period, which is the time once around a circle. Essentially one rotation. Alright, so now let's get into what you're going to have to do to use the force to calculate tangential velocity. So we know what you're going to have to find what F is, you're going to have to find what R is, you're going to have to find what the mass is. So the mass is pretty easy. So you're going to have to find the force, the mass, and the radius. So find mass is really going to be weigh it. Really not a lot to that one. The second one is you're going to have to find the force. Now this is much trickier. I'm probably going to be ready to give yourself a lot of room for this. Words I'm sure you enjoy me hearing saying. So find F. So you should probably try to right now try to draw a free body diagram of your cow. You should know, hey, it does have some force of gravity. Also, it's being held up by a string. So it has some force of tension. However, we don't really care. We only care because, remember, acceleration is inward only. What we care about is these lines on our force. So we need to essentially find what, if our angle is up here, I don't think I can write any smaller than that. If our angle is up there, that means that we are looking for the opposite. So we really want to know what Ft times sine of an unknown theta is. That is our force in the x direction, which is what we're looking for. Our force in the y direction would be our Ft cosine theta, and we know that this ends up being 0, so this is also equal to the force of gravity. My G disappeared over here. So it's equal to the force of gravity, which we can definitely find the force of gravity. We should be finding the mass in this. Alright, so then we now have two equations, two unknowns. We want to know what Ft is. So we can solve by Ft by dividing both sides by cosine theta. If we do that, we'll have Ft is equal to Fg over cosine theta. We also know Fg is equal to the mass times gravity. So we can plug that in as well. So this is mass times gravity over cosine theta. And we're in fact going to plug this whole thing in for f of t. To do this, I need more room. So I'm about to erase everything. So pause, finish it, because things are going to be erased. Alright, so I'm also going to move this up a bit so I have some more room. So from that, remember we had that ft is equal to mg divided by cosine theta, and that our x force is equal to sine of theta times ft. We can just plug all this in, so you get sine of theta times mg over cosine of theta. And then we have some fun things to do here, where all of this is equal to our overall force, and all of our force is equal to this entire equation, which is the force equals m times v squared over r. So we know that this whole thing is equal to mv squared over r, and hopefully now you realize why I didn't really specify how you'd find the mass, because hey, maybe we need to find the mass, or wait, if we have mass on both sides, if we divide by mass on this side and divide by mass on this side, they cancel out, so we don't really have to find the mass. From here we have now g times sine of theta over cosine of theta is equal to v squared over r. So remember, we are trying to find v. This is our unknown. So you're going to have to multiply both sides by r, move r over. So now r is on this side. So essentially we have v squared, I'm just rotating it, equals r times gravity is equal to sine of theta over cosine theta. Okay, well, we don't know the angle. How can we solve this? Well, with a clever bit of algebra and geometry, so I'm going to use this. So that's essentially our triangle. This is our ft. This is our, I'm going to say length, just to give it a different name. That's our length, and this is our radius. So we really want to know our radius. But if we said our angle was up here, that means that we know that sine of theta, I would probably write this under, but I'm running out of room and I don't want to erase it. Sine of theta is equal to the opposite, which is the r, over the hypotenuse, which is, I'm going to abbreviate with t. And that cosine of theta is equal to the adjacent, so L, over the hypotenuse, which is t. So you can essentially just, these are equivalent, you can plug them in for each other. So you're going to end up getting, this is also equal to rg, then we can just plug in rt, this is equal to sine, and then divided by cosine theta, which is L over t. Oh, hey, wait, we got multiple t's. We can cross them out, which again makes it equal to rg for r times L. We can put these r together, so you get r squared times gravity times the length. So ultimately, again, running out of room, we have v squared equals r squared times gravity times L. And these are all now manageable things. You know what gravity is. Gravity is 9.8 on Earth. L, you just have to measure your triangle. R, again, measure your triangle. We can measure that in real life. And then the last but not least is square root this. So you'd have v is equal to the square root of r squared g times the length. So yes, that was difficult, which is why I'm doing it for you, but ultimately you have to find this. So I would justify why you need to find those things. So what will you have to do? So what we're actually going to have to do, and I'm about to erase this. So again, I'm about to erase this. Copy it down, and we'll talk a little more about it. Alright, so this is theta, this is our tension from the rope, this is our length, this is our radius. So we know that F equals mv squared over r, and then we ended up solving for the fact that velocity is going to be equal to the square root of r squared times g divided by the length. Because remember, that length was division. I think I accidentally threw it in there as multiplication. So these are your ultimate goals. So you're going to have to find r and L. So part 3 of this is finding r. Key point, don't measure this. Here's why. If you do this, you're inevitably going to hit the cows, mess up your rotation, and have to keep doing your project over and over and over in an endless, repetitive loop. However, you can find L by essentially holding your hand up at the spot where you see the cow and then just put a ruler up to that height. If you're not sure what I mean, I can assist you with this later if you point to the spot and say, what did you mean? And then it's pretty easy. You can find T because that's the length of the rope. Or string. So, and if you have L and you have T, it's a right triangle. You can very easily solve for R. So don't measure, solve using L and T. Because if you have a right triangle and one side is R, one side is L, one side is T, it becomes an R squared plus L squared equals T squared. And now it just becomes a plug in and solve kind of equation. So this is the entire thing you're going to have to do. In the end, what you're really going to have to do is actually measure L and measure T. So write yourself a little note. These are the things you're going to have to measure. Everything else you just plug in or calculate from this. So after you measure these, go back and calculate R. Then you already know what L is. And you find your R. You know what G is because that's known. And then you just plug in and solve. So I would write a little something to your note explaining how to do this because it is tricky. So try to explain it to yourself in the justify section. So right now, pause the video, explain it to yourself or somebody else. Alright, so I'm about to clear all of this and on to how to do the kinematics version. Alright, and then for the kinematics, this is the velocity is equal to 2 pi r over t, where remember r is radius, t is the period or the time it takes to do one rotation. So hopefully you already know, hey, you do have to find r, and it's the same way as the last one, so you probably only have to do it once, by measuring L and T. So if you find L and T, you can solve for R using a squared plus b squared equals c squared, or Pythagorean's theorem. So the other thing we have to do is we have to find t, or the period, so the number of rotations. So this is, or excuse me, the time for one rotation. Hopefully you guys learned by the different cart projects. It's really hard to get the time accurately when it's going quickly and you have a small period of time to do it in. So, get it? Period of time. Anyway, so you need to let it go more than one rotation. So, go more than one rotation. So, but if you let it go more than one rotation, won't the time go up? Yes, but hopefully you can think, wait, if it takes it this amount of time to go around once, it should take twice the amount of time to go twice, 3 times the amount of time to go around 10 times, 10 times the amount of time to go around 10 times. So if your time is 10 times the amount, you would take your total time and divide it by the number of rotations, which hopefully you can count, right? You can just count, oh, it went around once and twice and 3 times and 4 times, and this will be equal to the amount of time it would take to do one rotation. And then for this, you actually got to measure it, so you're going to need to find your radius, your length, the time, and then from this you're going to have to, and then find your period, and you're going to have to solve basically for the height of the string, or essentially what your force tension is on. We should all do all those and then be able to solve for it. So I'm sorry this is a very long video, but now you should be able to basically get how to solve for these things. Yes, the kinematics one is definitely easier than the force one, and we will get back into kinematics after this. Either way, hopefully you have done this so I can let you use the cows tomorrow.